Hey guys, we're on page 352 in our new book, and it's going to be kind of a blast from the past. So we did some work with this stuff first quarter. Then we kind of took a break from it. We're going to bring it back a little bit here for a couple of lessons, because there was a couple things we didn't get to first quarter. So you'll hear me talking about translations, reflections, rotations, and then we have a new one called dilation. Okay, so like if you ever had your eye dilated or your pupil dilated, it just means like it makes it bigger or smaller. Okay, so if you dilate by something greater than 1, so like if you dilate by 1, it would stay exactly the same. If you dilate by something more than 1, it gets bigger. If you dilate by something less than 1, like 1/2, it would make your image smaller. Okay? So here we go. So we've got Albert. He graphed this trapezoid ABCD. That's the one on the top there. How can you tell whether the parallelograms are similar? So you'll see this also, this symbol right here. That just means similar. And so what we have to do is we just have to decide, like, is there a way we can move these shapes so that this one up here will just map onto this one down here? Okay? And the answer is yes. So we talked about before how to reflect. So what we can do is we can take these points and reflect them across, and it looks like it's going to be the x-axis. So if we go 1, 2 to the line, then we have to go 1, 2 past the line, and that's where D prime ends up. A starts up here, and we go 1, 2, 3, 4, 5, 6 to the line. So that goes 1, 2, 3, 4, 5, 6 past the line. And you're going to do that with every point. And once you do that, you end up with these points. Okay? And then our new shape, our orange shape, got smaller. So we have to kind of look at like something less than 1. So what could we multiply by? And basically what you do is you take your points. So like let's say we have C prime on our purple shape, which was 2, -2. So if I take 2, -2, and I look at and see where it went to 1, -1. 1, -1. So if that happens, we can look and say, well, what happened to these? Well, 2 went to 1, so 1 is half of 2, so maybe my scale factor is 2. And -2 went to -1, so that plays out well there too. So then let's just double check one other point. Let's say like B down here, B prime. So B prime looks like it's at 2, -6, and then the B double prime, or what they call H in this case, is at 1, -3. So we can look and see, did that go by half again? So 2 goes to 1, so half of 2 is 1, half of -6 is -3. So I could do the other points and really double check everything, but I think we can safely say that if we factor this or by a scale factor of 1/2, it is going to end up right on that KJ GH shape there. All right? So then we can say that ABCD is similar to GHJK because we can make this fit onto this with a series of transformations. Okay? All right, so you guys are going to do the same thing down here for the triad. For the triad, sorry if this is loud. For the triad, you're going to make what we call a proportion. Okay? So you're going to match up side lengths and see if they all come out to the same proportion. So I'll do the first one for you. So if I take this ABC triangle, this big one up here, and I flip it, oh shoot, that's ABC prime. Okay, so if I take this triangle down here, ABC, and I reflect it up here and make it bigger, this one down here, AC, is going to be this AC up here. So what I'm going to do is I'm going to take AC, so line segment AC, which is 8 inches over my line segment A prime C prime. This is what we make, how we make a proportion. We do a fraction. So it's going to be 8 over, and then my A prime C prime is 18. Okay, which 2 goes into both of those, so it would be 4 over 9. You guys need to see if those other sides come out to that same exact proportion. If they do, then these triangles are similar. Okay, so you guys go ahead and do the try it there. Finish that one off. Okay, then we'll go to the next page. We talked about rules when we were doing transformations. So the first thing you have to do is, it says we have these coordinates. The first thing you have to do is plot them. Okay, so here's those points plotted right here, J, K, L, M. And then it says graph the image of J, K, L, M by a dilation with a center 0, 0 and a scale factor of 3. So that's the first thing we need to do, is we need to take all our coordinates and multiply every single one by 3. Okay, so you'll notice that the 2 times 3 is 6, negative 1 times 3 is negative 3, 1 times 3 is 3, negative 2 times 3 is negative 6. So we're just multiplying by that scale factor. Okay, and that only really works when your center of dilation is 0, 0. So at least for right now, that's all we need to remember, is just multiply each point by the scale factor. And that's going to get us this. Okay, so it gets bigger, it gets further away from 0, 0. You can see that it kind of just kind of got bigger as it went out. Okay, so then after that we have to reflect across the y-axis. So hopefully you guys remember this rule. I don't know. I don't think you guys can see that on my screen, but just in case I moved it. The rule is you take the opposite of the x value, but your y value stays the same, which makes sense because the x value controls left and right, and when we reflect over the y-axis, we're only moving our shape left and right. We're not moving it up and down at all. That's why the y value stays the same. So in this case, the opposite of 6 is negative 6. The negative 3 stays the same. The 3, the opposite of is negative 3, but the negative 6 stays the same. And you'll do that to all the points, and you'll end up with this shape right here in the blue. Okay? And we can say that JKLM is similar to JKLM double prime because we can get there with a series of transformations. Okay? So we're going to be bringing some of those rules back. All right, and then the last one here is just saying, are these similar? So is A, B, C, D similar to E, F, G, H, and explain? So we're going to compare the coordinates here. So A on the first one was 4, 4, and the E was negative 2, negative 2. And then we had 8, 4, and then we had negative 4, negative 2, 10, negative 2, and negative 5, 1, and then we have that 2, negative 2, and negative 1, 1. So we would kind of have to think about how would we do this. Okay, so we can look and say, can I reflect it over? Well, no, because if I reflect it over, this big bottom part here is still going to be on the bottom. But we notice over here that the big side is on the top. So we can't do that. So then the next thing I would ask is, can I rotate it? Okay, and the answer is yes. If I rotate this 90 and then 180 degrees, that bottom part is going to be on the top there. Okay, and then this AB is going to end up down here. And then we know that this is just much too big, right? So then we have to dilate it by some factor less than 1. And in this case, the scale factor is 0.5. So we can do that same thing with the proportions and things, and see if if they match up. So for instance, DC is 1, 2, 3, 4, 5, 6, 7, 8 long. and that long side matches up with this long side, which is 1, 2, 3, 4 long. So if we take half of 8, that's 4. We could do the same thing with this one up here, 1, 2, 3, 4 long, and the side that corresponds with it is 1, 2. So we can tell that the dilation is half because our side lengths are half as long. Okay? So this would be a rotation first of 180 degrees, followed by that half multiplying by 0.5 for the scale factor. Okay? So they are similar because of that. All right? And then the last thing we're going to do down here is you guys try it. So it says graph the image JKL after a reflection across the line x equals 1. Okay? So the first thing we need to do is draw that line. So x equals 1 means that it crosses the x-axis at 1. So you're just going to go to the x-axis, go to 1, and then draw a line straight up and down from there. Okay? So then you're going to you're going to reflect JKL across this line first, so it's going to end up over here somewhere. Then you're going to write down all the points for that one, and then it says multiply by a scale factor of 1/2. Okay? Wait. Graph the image of JKL after a reflection across the line x equals 1. Yeah, followed by a dilation scale factor of 1/2. So then you're saying is JKL similar to PQR? So you'll have to look at side lengths and see if they match up. Okay? So go ahead and do that one. This video is getting long, so I'm going to stop it right there. I'll talk to you guys soon.